Okay, team. I neglected to put this video out yesterday. I got a little caught up. I'm sorry, but I wanted to make good on my promise. So I wanted to throw you a little bit more review for the final exam, which is covering chapters 9 and 10. So I went over a couple problems from chapter 10 that I thought would be helpful, and I'm going to do the same for chapter 9 today. I will be posting an announcement today about the final exam. So that should be good. It will be on Thursday, so just a heads up. So that's when you need to be ready by and have all your assignments in by Thursday. And otherwise, there's not a lot to report other than this is the last lecture, which is great. I think we're all excited. And the only thing I want to say is I'm sorry about the video. That Zoom did something, changed something in update, and the video is more cropped than it used to be. And so it means that I have to like raise my camera up more so you can see more of the page, whereas I used to be able to capture the whole page. Anyways, not a big deal. Last video of the semester anyways. So we're looking at chapter 9, which had to do with the confidence intervals, constructing confidence intervals for estimating parameter values, and specifically estimating the sample mean and or estimating, sorry, the population mean and estimating the population proportion. So what I namely wanted to do with this little session is show you some calculator tools that you can use to make those calculations very, very simple. So despite all the stuff that I showed you and all the theory that you had to learn, the calculator, excuse me, the calculator does it all. So I wanted to show you how to do that. So I'm looking at chapter 9, and I've picked just 2 problems from the chapter 9 review exercise section. So this is number 8, and there's a bunch of wording, blah, 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 but they basically tell us that the sample mean was 54.8 and the sample standard deviation was 10.5. They then ask us to construct numerous confidence intervals based on those 2 statistics. So I'm going to show you how to do that the quick and easy way, right? So part A asks us to construct a 90% confidence interval with the sample size equal to 30. So check this out. Now, the thing to remember is for estimating the population mean with an unknown standard, with the unknown population standard deviation. So we know the sample standard deviation, but we don't know the population standard deviation. Remember that we had to use the t distribution instead of the z distribution. Okay, so I'm going to show you how to use the calculator to construct this confidence interval, but you have to remember that fact. So I hit the, I'll zoom in. I hit the stat button. Then I cursor over to tests. And then I go down till I get to t interval, number 8, t interval. We're using t because for the with an unknown population standard deviation, we have to use a t distribution, okay? And that will bring up a menu system, and it'll ask us for all the statistics that we know, right? So they ask us for the sample mean, which was 54.8. They ask us for the sample standard deviation, which is 10.5. They ask us for the sample size, which in this first part was just 30. And they ask us for the confidence interval, which we put in decimal form as 0.90. So you see, you put in all the data, go down to calculate, hit enter, and it spits out an answer. Amazing. So this right here, parentheses, answer, comma, answer, parentheses, this is your interval right here. Already calculated for you. You didn't have to do any of the work. Amazing. So You punch that into your calculator, it spits out an answer, and you get to move on with your life. Don't say I never did anything for you. That's how you can use the calculator to construct a t-interval, right? So we just put in all the statistics, all the information that we have, and it spits out the interval. So we can do it again. Now it says construct a 90% confidence interval with the sample size equal to 51 instead of 30. So let's see what happens there. All right. So again, we bring up the same function, stat, test, cursor down to t interval, then put in all the data. It should store most of the data, so we're only changing the sample size. The confidence level is the same. Hit enter, and booyah, we've got our confidence interval. Oops. So that's 52.336 up to 57.264. Couldn't be easier. All right, let's do it one more time. So now they say construct a 99% confidence interval with the sample size equal to 30. So again, we bust out the calculator. Get out of the clear. Stat, test, t interval. And now we just change all the data. All of those are the same. Now we're just changing the sample size and the confidence level to 99. Calculate. And we get a new confidence interval of 49.516 to 60.084. Amazing. Okay. So in a matter of a few minutes, just using the calculator, it's able to generate all three of these confidence intervals very quickly. Excuse me. So this is a tool for calculating confidence intervals. It doesn't mean that it's going to do the thinking for you, right? So that you can be asked conceptual questions about these confidence intervals, and you need to understand the underlying concepts, or else just knowing what the values of the confidence interval aren't going to be much use to you, save for those few problems where they just ask for the confidence interval. So, you need to understand some of the trends. That's what we're doing here. So we've constructed 3 confidence intervals. The first 2 have the same confidence level, but a sample size of 30 versus a sample size of 51. So if we compare those 2, increasing the sample size effectively narrowed the confidence interval, right? So this is a narrower interval than this interval, or this is a wider interval. So this should make sense to you. When you increase the sample size, you increase the precision of your estimates. A larger sample size is going to be a better representation of the population than a smaller sample size. So let me get my plug. Right. So a larger sample size will give us a better approximation of the population, and therefore the confidence interval will be smaller. more precise. A smaller confidence interval means there's less error, right? The confidence intervals, remember how they're constructed. You have your estimator, and then you subtract the critical value times the it's the standard deviation. So for the parameter, here we go, something like this. The exact form doesn't matter. Mainly what the point you want to make is that the size of the confidence interval depends upon this factor here, the critical value times the standard deviation for your estimator, which we call the margin of error, right? So we call it error, the margin of error, because the more error, the wider the interval, right? And a wider interval has more error. A narrower interval has less error. So we would expect less error from a larger sample size. Now, if we look at the third option here, we've increased the confidence, but we've returned to the same sample sizes in part A. So if we're comparing part A and part C here, what has happened? Well, this interval versus this interval, this is a wider interval than this interval. They both have the same sample size, but now we've increased the confidence. So let's think about that for a second. Why would increasing the confidence widen the interval? It's sort of counterintuitive. You'd think greater confidence, narrower interval, more precision, but you're thinking about it the wrong way. If you think about it like this, if you make a statement, if you place a bet on an outcome, the more possible outcomes that are like kind of caught in the umbrella of your guess, the more likely you are to be right. That was very poorly phrased. So here's the idea. If the interval is wider, then you can have greater confidence that somewhere within that interval will be the actual value of the parameter that you're trying to estimate. A wider interval means there's more room. There's more room, there's greater confidence, because there's less options for error. There's less options. There are less places for the parameter to hide, right? That if you widen the interval, then where could it be? Think of your bell curve again. If you have a narrow interval, then a narrower confidence interval, then your parameter value could end up being somewhere outside of that interval. There's more room for it to hide. But a wider interval means there's less room for the parameter to hide, less options for the parameter less options for the parameter. And also, as you widen the interval, the space that's left is and less likely, right? It's, your frequencies or your distribution is smaller and smaller out towards the tail. So there's less and less likelihood of finding a parameter out there anyways. So it's sort of you can see it in two different ways. But the main idea here is, for a fixed sample size, increasing the confidence increases the width of the interval, as opposed to fixing the confidence and increasing the sample size. If we increase the sample size, the interval narrows. So those are the observations that one has to make and be clear about. The calculator can generate the confidence intervals for you, but it cannot do the interpretation for you. So you need to understand the trends and how this all works. Okay. So one more problem. This is number 15 from that review section. And here we're estimating the population proportion. And so I just wanted to show you how to use the calculator to do this as best I can. So number 15, they tell us that 58 out of 678 men have high blood pressure in a particular sample. Okay. Part A says calculate the point estimate for the proportion with high blood pressure. All right. Point estimate. The only point estimator for the population proportion is the sample proportion, p hat, which is simply x over n. So that will be 58 out of 678. And if you punch that into a calculator, you get round about 0.0855. Okay, so point estimator, that's always going to be the sample estimator, right? The sample mean or the sample proportion. Okay, now they ask us to construct a 95% confidence interval. Okay, so let me show you how to use the calculator to do that. Awesome. So here we are working with proportions. So that's the main thing to bear in mind. So to use the calculator to generate this confidence interval, I hit stat, then I cursor over to test, and then I'm going to go down, down, down till I get to the 1 prop z interval. That's letter A. I select that, and let me just, pull that back up, sorry. 1 prop z interval. And this brings up a menu system. 1 prop z interval asks for the x, the n, and the confidence level. Couldn't be easier. And I've already got the data already put in. So it was 58 for the x, 678 for the n, and our confidence was 95. So 0.95. Punch that into the calculator, it immediately generates a confidence interval for you. So 0.0645 to 0.107, roundabout. Easy peasy. Calculator does it all for you. Okay, so that's confidence intervals. I've shown you how to calculate confidence intervals using the calculator with great ease. This should immensely simplify that process for you. So you don't have to find the critical values or worry about the margin of errors or any of that stuff, unless the problem asks you directly to do that. So it's not like you need to just completely dump that stuff out of your brain, but this does speed things up when you're not expected to do everything by hand. So I thought that would be helpful. Part C asks us to calculate the sample size needed to estimate the population proportion within 3% with a 95% confidence. Okay, so we got to remember how this all works. We're trying to find the sample size. They've told us two things. They've told us the confidence level is 0.95, and they've told us within 3%. So that's actually your margin of error, 0.03. So you've got your confidence level and your margin of error. Now you need to calculate your sample size. So I believe there may even be a way to get the calculator to do this, if I remember correctly. Maybe not. I thought there was. Okay. So this is one that you have to do by hand. You've got to remember how to calculate these guys. And we went over we derived the formulas last time. So, it depends on whether you're estimating the proportion or you're estimating the mean, which formula you're going to use for the sample size. But for the proportion, you remember you use the formula N equals P hat times 1 minus P hat times Z alpha over 2 over E squared. So that is your formula. This is one of the few that you need to do on your own. So confidence level tells us your alpha value, right? Remember, the confidence level is the same as 1 minus alpha. So if 1 minus alpha is equal to 0.95, then alpha must be equal to 0.05. If alpha is 0.05, then alpha over 2 is 0.025. I'm trying to get this all on the same screen. So you have to know your alpha over 2 value. And once you know your alpha over 2 value, then you can calculate the Z here. So remember how that works. You're going to use the inverse norm to get the Z alpha over 2 value. Second vars, inverse norm. And what are you going to put into the inverse norm? You're going to put 1 minus 0.025. So 1 minus alpha over 2. And that gives us a Z value of 1.96. So that's our Z alpha over 2 value. So now we can, I'll write it over here. Z alpha over 2 was 1.96. We got that from the inverse norm function. So now we just punch everything in and get a number, right? P hat we have up here, 0.0855. So 0.0855 times 1 minus 0.0855 over 1.96 over our E value, which was 0.03, and that's squared. So this is what we're calculating. Put it into a calculator. That is 0.0855 times 1 minus 0.0855 times 1.96 divided by 0.03. Quantity squared. Enter. We get a fraction, 333.74. With sample size, you always round up no matter what. So you're not really rounding up. You're just always, you're rounding up, but you're not using rounding rules, right? So it doesn't matter how much of a fraction you have here. If it was 333.0000001, then you'd round up no matter what to 334. So that is the required sample size in order to have our estimate be within 3% of the sample proportion with a 95% confidence. There we go. Okay. So I've shown you how to do the calculator stuff. Hopefully that simplifies things for you quite a bit. Otherwise, you've got to remember all the concepts and some of the formulas. You can use a formula sheet for the final. I don't have any problem with that. The final is going to be online. It's just going to be an online test, but it's going to be scheduled at a specific time. that I'll post here just after I upload this video. And it's going to be timed. You're going to only have one attempt. It's a real exam, but it's open notes. And yeah, so that's basically it. If you have any questions going forward, let me know. Otherwise, you know the deal. Final exam will be on Thursday at the posted time. I'll post that here in a second. And you have to have all your assignments turned in, everything buttoned up, no loose ends. I will not be merciful when it comes to this. I really, really, really don't want to get a bunch of emails from people saying, but wait, I didn't do this one assignment. And no, I don't care. I really don't care. You've got to do it before the exam. Final word. All right, y'all. Good luck.